So let's now consider a signal flow graph simplification question from 2017. Here we have a signal flow graph, and we've been asked to simplify it and to come up with the overall transfer function of the system. So let's look at this system. As we can see, there's a forward path in this system which is AS and BS in series, and we know that two things in series can be replaced by a single block which has the transfer function of the product of those two things in series. So the forward path is going to be composed of AS times BS. Similarly, the feedback path is also two things in series. It's CS and DS in series. So we can replace the feedback path with a single expression, CS times DS, because basically they multiply. So we've got the forward path and we've got the feedback path. Now we know from the simplification expression for a negative feedback circuit, if we have a forward path G and a backward path H, which is subtracted, that is equivalent to a single block where we have G divided by 1 plus G times H. So all we have to do is substitute in the forward path and the backward path. So it's going to be forward path divided by 1 plus forward path times backward path. We substitute in the values that we have from the forward and the backward paths. Forward path AS, BS at the top, and then at the bottom we have 1 plus AS, BS for the forward path multiplied by CS, DS for the feedback path. And that's the solution. The second question is to simplify this drawing here, this signal flow graph, which is just a tiny little bit more complicated, but not very much so. We see the only thing here which stops us immediately solving the problem as quickly is the fact that we are actually tapping off something here between these two transfer functions. So what we want to do is we want to move this tap off point so we can actually tap it off at the end, and if we did that, then we can then combine these two together. Currently we can't combine them together because we're taking something off in the middle. So, but if we can tap this CS off at the end, then we can then finally combine these two together. We can already combine these two together, and this is going to be a feedback path here. So let's look at doing that. First of all, we're going to move this tap to the end point, and we can do that. So just do that again. What we see is if we tap off here, we're not multiplying anything by BS, but if we tap off at the end point, the signal here gets multiplied by BS. So we've got to divide by BS in order to get rid of the effect of having tapped off after this. But now what we've done, we've cleaned up this bit so we can combine those two together. We can easily combine those together away. Then this is then a feedback system that we can then also immediately write down as being a simplified system. So the single feedback path now, like just to write it down step by step, this feedback path now, rather than being C of S, is now C of S divided by B of S. So this is this path here. Now let's tackle this block here. We've got this block here. This is we can represent that as a single forward path now. And we do that if we represent, obviously this is composed of a forward path and a feedback path within it, right? But the overall thing from here to here is actually a feed forward path. So let's build up what this block can be represented as. And as we can see, it's got a forward part AS-BS, right? And it's got a feedback part DS-ES. And in order to simplify this, we have the forward path divided by 1 plus forward path times return path here. So we can represent the block there by this function. So now we've got the forward path of the overall system and the feedback path of the overall system. And again, we can then simplify once more using a single expression saying we've got the forward path divided by 1 plus forward path times backward path. And we just substitute this expression here and this expression here into this formula. we end up with this nasty denominator term at the top and the bottom. But to get rid of this, all we have to do is multiply through by 1 plus AS, BS, DS, ES, and it'll get rid of that here. Get rid of that here. It'll appear there. So let's do that. And we end up with this expression here, which we can then, if we wish to do so, well, basically what we do then is we cancel out the BFS's, and we end up with the final result of AS, BS divided by 1 plus AS, BS, DS, ES plus AS, CS.